Alright, so this video we're going to talk about making Lewis structures for covalent compounds. The general rules for this, and we will expand upon each of them. The rules are first that we need to make a correct skeletal structure for the molecule. We need to calculate the total number of electrons by adding up the valence electrons for each atom. We need to then distribute those electrons among the atoms and give octets or duets if it's hydrogen to as many atoms as possible. And then if any atom lacks an octet, then we need to form double or triple bonds. So the first step is writing a correct skeletal structure, which is talking about the location for each of the atoms in the molecule. Some general rules that we follow: the atom that has the lowest electronegativity will typically be in the center. So remember, electronegativity, this increases as you go up the periodic table and to the right. So fluorine is the most electronegative. So we want lower electronegativity in the center. If carbon is present, then we're going to go ahead and put that in the center typically. Hydrogen is always going to be terminal, meaning at the end, since it only has one electron available for bonding. Molecules most of the time will be symmetrical, so whenever we're laying these out, typically we make them symmetrical. So let's do an example. So a skeletal structure for carbon dioxide. So for this skeletal structure, we have carbon in the middle, which is what you see here, and then we have oxygen around the outside because that helps to make it symmetrical. For our next step, we are going to calculate the total number of electrons for the Lewis structure by summing up all of the valence electrons for each element. So, carbon has 4 valence electrons, oxygen has 6, and we have 2 of them. So we would have 4 valence electrons for carbon plus 2 times the 6 valence electrons for 16 total electrons. The next step is that we're going to distribute electrons among the atoms, giving octets to as many atoms as possible. The first step, we're going to place a bonding pair between each pair of atoms. So we put in what we call a bonding pair, and then we distribute the remaining what we call lone pairs, so pairs that aren't used in bonding, to the terminal atoms first, and then return to the central atom. We distribute electrons in pairs, not in singles. So we work with the bonding electrons first, and so what that means is that we are going to put our electrons in between the carbon and the oxygen first. So we've used 4 of the 16 total electrons that are available. Now we do lone pairs, meaning not bonding, and we put them around the terminal atoms. So terminal would be oxygen in this case. So we put 2, 2, 2, and then 2, 2, 2 around these oxygens. And what happens is that now we have 16 of 16 electrons used. However, we have to go back and make sure that each atom has an octet. So if we count around oxygen, what we find is that we have 8 electrons around this oxygen, so there's 8 there, so it's happy. And we have 8 electrons around this oxygen, so it is also happy. But if we count the electrons around carbon at this point, right now we only have 4 electrons. And so because of that, we need to make some adjustments. So if any atoms lack an octet, then we're going to go ahead and form a double or triple bond to give them octets. What this means is that we'll move the lone electron pairs from the terminal atoms into the bonding region with the central atom. So how this looks for carbon dioxide is that we take 2 pairs, so we take 1 pair from this side and move it to the middle, and 1 pair from this side, move it to the middle. And what ends up happening then, if we look at everything here, so we have 1, 2, 3, 4, 5, 6, 7, 8 electrons for oxygen. We have the same 1, 2, 3, 4, 5, 6, 7, 8 electrons for this oxygen on the right, and then our carbon also has 8 electrons, and so everything has a stable octet. Whenever we do double or triple bonds, for example, if it was an oxygen diatomic, we move the electrons into the center as shown, and then our Lewis structure will either be this or like this, keeping in mind that the double bonds are going to represent 4 total electrons, which is what we see here. And then our triple bond, which is what would happen with the nitrogen diatomic, is representing 6 electrons. So if we do another example for the Lewis structure for carbon tetrachloride, we're going to put carbon central. It's the least electronegative, plus it helps us to make a symmetrical molecule. So we would have carbon in the center, and then chlorines at each of the 4 points. The next step is going to be to count up the electrons, and so we look at the valence electrons. So we have 4 valence electrons for carbon, plus 4 times the valence electrons for chlorine, which is 7. So we have 32 total electrons. We're going to work with our bonding electrons first, so we put electrons between our carbon and our chlorine for each of these, and that takes care of 8 of the 32 electrons. We put lone pairs around each of the terminal atoms, which in this case are chlorine, and in this case we do 32 of 32 used. Now we'll check to make sure that everything has an octet, and what we find is that it does. So we have this chlorine has 8, this chlorine has 8, this chlorine has 8, and this chlorine has 8, and if we look at our central atom, which is carbon, carbon also has 8. We can also draw this with lines for the bonds, and then our chlorine with the lone pairs around the outside. This also is a good representation of a Lewis structure. More typically, we'll draw our final structures like this to represent our bonds, which would be our single bond, which is representing our 2 electrons. Right, so let's go ahead and work on this together. You're welcome to pause the video and try it yourself and then check your work. So our first step is to draw our skeletal structure. In this case, we just have 2 elements, so I'm just going to draw like that. We're going to then count up our valence electrons, and so we have 4 valence for carbon, and we have 6 valence for oxygen, so we have 10 electrons that we need to place around the atoms. We'll start with our bonding electrons, which will be between both, and then we'll go ahead and we will fill in around them. I'm going to go ahead and fill oxygen first since it's more electronegative, so technically it would have the electrons first. So I'll make a stable octet there, and that takes care of 8 electrons, and then I have 2 more electrons to take care of. Now, the next step after we've distributed all the electrons is to make sure that everything has a stable octet. I don't know why those electrons don't want to stay. Make sure that everything has a stable octet. In this example, oxygen does have a stable octet, but carbon does not. And so what we need to do next is we need to go ahead and move some of these lone pairs in the middle. So if we take this bottom pair of electrons and move it into the middle, that gives us 2 more in the middle. And we count again. Oxygen, still happy. Carbon, still not happy. It still needs more. So I'm going to take 1 more pair of electrons, move them to the middle. Now, whenever we count, we'll see that we have carbon has 2, and then we have 3 pairs of electrons shared, and then we have oxygen that also has the 2 lone electrons. Now, if we look at this, we always want to make sure that we've counted the right electrons, so we have 2, 4, 6, 8, 10 electrons, so that's good because that's what we originally have. Our final Lewis structure is probably best drawn like this, though it's not incorrect the other way. And so we have a triple bond for carbon monoxide, and this is what you should have drawn for your structure. So let's do another one. So we will draw for H2CO, and so first we need to start by drawing our skeletal structure. Our skeletal structure will put carbon in the center, and then I'll put hydrogen and oxygen. We'll count up our valence electrons next, and so we have 2 valence electrons from hydrogen. Sorry, we should have 2 times the 1 electron, plus we have 4 electrons from carbon, plus we have 6 electrons from the oxygen, and so in this case we would have 12 electrons. Alright, so distribute the bonding pairs first. So we do bonding between the central atom and the terminal atoms. And then we go ahead and we give stable octets and duets. Hydrogen needs a duet, which means that it needs 2 electrons, and then everything else needs an octet. So hydrogen's already happy in the case that we've drawn. Now we just have to distribute the rest. So we have 1, 2, 3, 4, 5, 6 distributed, 7, 8, 9, 10, 11, 12. So we've used all of the electrons, but now we have to double check and make sure that everything's happy. So if we look and we make sure that everything's happy, hydrogen's good because it has 2 electrons. This hydrogen's good, it has 2 electrons. And oxygen is good because it has 8 electrons. When we look at carbon, however, carbon, the central atom, has only 6 electrons. So we need to make a double bond. And so what we'll do is we will take some electrons from oxygen and move them into the center. And so it will end up looking like this, where now we have 2 pairs of electrons between the carbon and the oxygen. And if we drew our Lewis structure then with the bonds, with lines for bonds instead, we would have carbon bonded to the hydrogen and then double bonded to the oxygen, which has 2 lone pairs. If we go back and double check, make sure we have 12 total electrons, which is what we need, and everything has a stable octet or duet. If you have any questions, please let me know.